Right, what's up, Joel? So today we are going to be learning about congruent figures and their corresponding congruent parts. And so in reality, we're kind of learning about the difference between congruent and similarity. Okay, there is a difference between congruent shapes and similar shapes. So if you have any questions after this, please let me know. You do have a sub today, so I was hoping that I could test you on this unit tomorrow. And so please make sure you email me after today and tell me if you feel like you're ready to test tomorrow. If you're not, that's 100% okay. Or we can test on Thursday, but I was hoping you can hang out with us and relax on Thursday, depending on how people are doing. So just keep me updated. So congruent figures have the same shape and size. Sorry, I did the opposite, but same size and shape. Their corresponding parts matching their sides and their angles are congruent. Okay, so if they do not have the same size and shape, they are not congruent figures. So their corresponding parts are congruent, meaning matching sides have the same length and matching angles have the same angle or degree measure. And so let's kind of look at an example here. We can name our congruent angles here by saying that first let's do our E and S. Angle E is congruent to angle S. Angle D is congruent to angle R, and angle F is congruent to angle T. And we could do the same thing with our sides. We can say that side ED is congruent to side SR, side EF is congruent to ST, and side DF is congruent to RT. And then we could also say that triangle is congruent by stating that triangle EDF is congruent to triangle SRT. Now, you really have to be careful when you're doing a triangle statement, and you have to list the corresponding vertices in the same order. So if you do E first, the angle that is corresponding to that is congruent to it has to be the first letter as well. So example 2, let's kind of look at this. If HIJK is congruent to LMNO, list the corresponding parts. And so we can kind of go through this. We can see that angle H is corresponding to or is congruent to angle L. We also know that angle I is congruent to angle M. Angle J is congruent to angle N, and angle K is congruent to angle O. We could also do these sides. Side HI is congruent to LM, and I think you're getting the idea. So kind of look at these statements and let me know if you're lost at all, but in reality, that's how we state it. Another example here, we can use what's given to us and find missing angles. So in the diagram, NPLM is congruent to angle or EFGH. Find the value of X and then find the value of Y. And so we know that E is going to be the same. So if we flip this down, it's going to be congruent to angle N. And so what we can do is change the locations of what we already know and solve for those missing pieces, right? We know that line LM is equal to line GH, so put 8 equals to 2x minus 3 and solve, and x is going to be 5.5, and we could do the exact same thing with y, but with angles. We know that 72 has to equal 7y plus 9. We can go ahead and subtract 9 and then divide by 7, and y is going to be 9. Do the same thing here. If we look at these two triangles, we can kind of, I know it's turned, but that doesn't mean that they're not congruent. And so we can kind of say that if angle Y is congruent to angle S, we can do 4a minus 4 is equal to 48, add 4, divide by 4, and a is 13. We do the exact same for B. Oops, sorry. To figure out B, knowing this information, we know that the inside of a triangle has to equal 180 degrees. And so you can go from there if you're lost or if you're not really sure how to do the rest. Write the triangle congruent statements for the two triangles below. And so this statement we would do triangle FGH is congruent to triangle JKH. Notice how the H is both at the end, and then there's congruent statements that are congruent to the same triangle, or the angles are also first and then second. If you're given that triangle AUS is congruent to triangle KAP, name the 3 pairs of congruent sides. And we could get something like this. I'm kind of going through this. I'm thinking you get the idea, but let's kind of keep going. If 2 angles of one triangle are congruent to the 2 angles of another triangle, then the third triangle or angles are congruent. Okay, so this is kind of like a third angle theorem, meaning that if you have 2 angles of a triangle are congruent, that third angle has to be congruent, regardless of what we think or what we already have. If 2 of them are congruent, the third also has to be congruent.